All right, here we go. All right, exponential decay function. If I have y equals a times b to the x, this is a decay if a is positive and b is a number between 0 and 1. The decay factor is b. So, what I want to do here is you should have some space here, hopefully. So now we've talked about decay. Yesterday we talked about exponential growth. Now I'm going to give you an equation and I want you to tell me, is it decay or growth? So letter A, y equals 2 times 1/3 to the x power. What do you think it is? What? It's not growth.
Decay.
You think it's decay? Okay, yes, it is decay, but do we know why? Yeah, Noah?
It's less than 1.
Okay, the b value. If b is between 0 and 1, that's what makes it growth or decay. Okay? So let's try another one.
Good job.
Yeah, I had 50-50 shot on that one. Okay, how about this one? Because it's growth. Now, what I have some students do is they say, oh, it's a fraction. It's a fraction. So, but it's not. It has to be between 0 and 1. This is 2.5, right? So it's growth. All right, so let's look at example 1. It says we want to graph y equals 1/2 to the x power. It says make a table of values. So we're going to start with our standard table from -2 to 2. And we're going to plug that in. So I get y equals 1/2 being squared is 1/2 times 1/2, so that's 1/4. If I do 1/2 to the first, that's just 1/2. 1/2, what's 1/2 to the 0? 1, good job. Now, here's where it's going to get interesting. If I do 1/2 to the -1, does anybody remember when you have a fraction to a negative exponent, what does it do to the fraction? It flips it, right. So this is going to make it 2/1, but that's just 2, so that's 2. And then if I do 1/2 to the -2, that makes it 2/1 or 2 squared, which is 4. So let's plot this. I have -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. Notice you're going to make it approach the x-axis, but it does not touch it or cross it. There's a horizontal asymptote here as well, at y equals 0. The y-intercept is at 0, 1, and there's no x-intercept. So like I mentioned in 7.1, I'm going to mention it again as you're finishing your graph. It is assumed, it's part of graphing an exponential growth or decay, that you will draw the horizontal asymptote and you will write the equation for the horizontal asymptote, as well as stating your x and y intercepts, okay? That's a given. All right, now what I want to do is I want to take a moment and connect to yesterday's lesson. Yesterday we looked at y equals 2 to the x. And that was 2, 4, 1, 2. Okay, here was the really rough, quick sketch, okay? Now I want to compare these because there is a connection to 1/2 to the x and 2 to the x. Can anybody tell? What do you mean?
It's...
Use the proper mathematical language. Instead of flip, what's the word we use? Not a reciprocal, it starts with an R though. A reflection, okay. It's a reflection, but this time it's not over the x-axis, is it? It's a
Over the
reflection
y-axis.
over the y-axis. Now let me explain why. This is very, very cool. Watch what happens here. If I do, watch this fancy mathematics, okay? What if I have y equals 1/2 to the x? 1 over 2 is 2 to the negative 1, right? And that's 2 to the negative x. So, now watch this. When we had, say, y equals x squared, it was a u that opened up. But when we put a negative out front, it reflected it over the x-axis. Now, if you take your x and replace, not with it out front, but if you replace the x with a negative x, it causes a reflection over the y-axis. Isn't that cool? The crowd goes wild. Oh my gosh. You see that? Okay. I've had some M&Ms, so I'm good. I'm good now. All right, let's try example 2, letter A. Woo, yeah. I am. I'm so tired. I can't even
No,
see
me too.
straight. Woo, my eyes are bloodshot too. Okay, let's do our standard table here. So I would have y equals 2 times 1/4 being squared. 1/4 squared is 1/16. 2 goes into 16 8 times, that's 1/8. And you also see this wonderful connection. Like the higher up you go in math, it's like you get more and more things revealed to you why you wanted to be doing that. In pre-algebra and algebra 1, do you remember? You worked on 2 times 1/4 the quantity squared, and you did please excuse my dear Aunt Sally. Here's a punchline. You have to use it to evaluate functions and to graph them. So that's why you were doing that. But you had to get to this point to be able to use it. All right, so if we do this one, that's 2 times 1/4. That reduces to 1/2. 2 times 1/4 to the 0. Now that 2 is not to the 0 power. It's 2 times 1 is 2. Okay, now watch. This is where it's going to get tricky. Again, please excuse my dear Aunt Sally. You have to handle the exponents first. So this is 2 times, and it's going to be 4 to the first. You guys see how that's working? Okay. So then I get y equals 2 times 1/4 to the negative 2. That's 2 times, I flip it. 16 times 2 is 32. All right, I'm going to go by 5s. You can go by 4s, 6s, whatever you want. It's fine. I went by 5s. And you are just going to estimate because we're doing this freehand. So I'm going to go -2 and I'm going to approximate 32. I have -1/8, so I need to approximate that. 0/2. Notice, boy, 1/8, that's getting awfully close to the x-axis, but make sure you don't make it touch. Make sure you draw your horizontal asymptote on the graph and you state what it is. It's y equals 0. If you put HA equals 0, I'm going to mark it wrong. That it does not describe a horizontal line.